Like, good afternoon, everyone. I, Apurva Jain, Assistant Professor, BCA Department, welcomes you all to a one-day international seminar on innovative paradigms of machine learning and IoT in human life, organized by BCA and CSE Department of JIMS Engineering Management Technical Campus. Now I invite you all to the lamp lighting ceremony. Let us now join our hands together for Saraswati Vandana.
या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतं शङ्करं प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा
JIMS Engineering Management Technical Campus is approved by AICTE and affiliated to Guru Gobind Singh Indraprasth University, Delhi. The institute has been established to cater to the growing needs of higher education in the country. In order to face the challenges of globalization and liberalization in the field of engineering, the institute has endowed its faculty and students with modern technologies, skills, and attitudes. The institute has an excellent infrastructure in support of high quality teaching, learning, and research activities. The Wi-Fi enabled campus has the state-of-art infrastructure comprising of an environment-friendly administrative block, academic blocks, and spacious classrooms. I would now request the convener of the seminar, Dr. Ruchi Agarwal, Head of Department BCA, for the welcome note. Ma'am, please.
Very good afternoon, Honorable Director Sir, our speaker Dr. Ayub Khan, all HODs, faculties and students. I, Dr. Ruchi Agarwal, HOD BCA, feel honored to welcome you all to this international seminar on innovative paradigms of machine learning and IoT in human life. Machine learning and IoT play a significant role in innovation, entrepreneurship, and information processing systems. It is a rapidly growing field. The machine learning is an essential part of pattern recognition, object detection, classification, data mining, and speech recognition. In addition, IoT has important significance over machine learning in application of smart city. The aim of this seminar is to provide an exposure to both basics and recent advances in machine learning and IoT to the students, faculty, and research community. Now, I would like to introduce our speakers of the seminar. Our first international speaker is Dr. Mohammad Ayub Khan from University of Bisha, Kingdom of Saudi Arabia, who will deliver a session on privacy issues in IoT. Our second international speaker is Dr. Shruti Kohli, lead data scientist from DWP London, who will share her knowledge on trending applications of machine learning models. Our third speaker is Dr. M. Tanveer from IIT Indore, who will talk on large-scale machine learning algorithms. I can assure you that the session will be very informative. I have known and worked with Dr. Ayub and Dr. Shruti for many years, who have diverse expertise in their domain. I once again welcome you all to this international seminar and hope that you all will have a great time ahead. Thank you.
I would now like to call upon our director, sir, Dr. R.K. Raghuvanshi, to address the audience. Sir, please.
Yeah, thanks, Apurva. A very good morning to you all present here. Honorable Chairman Dr. Amit Gupta, under his able guidance, acumen, and leadership, this institute is running and flourishing. Our eminent speakers, Dr. Mohammad Ayub Khan, Associate Professor, University of Bisha, Kingdom of Saudi Arabia. Hello, sir. Good afternoon. Our next speaker, Dr. Shruti Kohli, a lead data scientist, DWP London, and Dr. M. Tanveer, Associate Professor, IIT Indore. All HODs, especially Dr. Ruchi and Dr. Vikas, who organizes this event, faculty members, member of organizing committee, Apurva, and other faculty members and dear students. It's an immense pleasure that I take this opportunity to welcome you all on this international seminar on innovative paradigm on machine learning. I must thank our speakers who spared this precious time from their busy schedule. They are the special people who believe that the entire world is driven by a conscious knowledge, and that is why they are available here to share their knowledge with our student. And this was only the purpose to organize this event. So thank you very much, sir. Thank you, Dr. Ayub. And I must thank all the speakers who really spared their valuable time for a noble cause. So, once Emmy Staple, as far as the pursuit of this the seminar is concerned, that is IoT machine learning. So once Emmy Stapleton told, she said, we are entering a new world. The technologies of machine learning, speech recognition, and natural language understanding are reaching a nexus of capability. And the end result is that we will soon have artificially intelligent assistant to help us in every aspects of our life. However, so many data scientists, lead scientists, and people, those who are working on these IoT, machine learning, etc., they have some criticism also, because the brain has artifices its intelligence and so many things they have narrated. But ultimately, it is a big boost. The technology is a big boost nowadays. So once again, I wish you all good luck and hope this program is going to be a big success in terms of knowledge enhancement in our students. So thank you so much for listening to me patiently. Over to Apurva.
Thank you, sir. Thank you so much for your kind and valuable words. Let us now welcome our first speaker for today's session, Dr. Ayub Khan. He is a senior member of IEEE. He has received a PhD from Jamia Millia Islamia, New Delhi, and a Master of Technology in Computer Science and Engineering from Guru Gobind Singh Indraprasth University. Presently, he is an associate professor at the University of Bisha, Saudi Arabia, with interest in the IoT of things, smart cities, ad hoc networks, etc. He has more than 15 years of experience in his research area. He has published more than 100 research papers and books in reputed journals and international conferences. Now I invite Dr. Ayub Khan, sir, to start the session. Sir, please.
Thank you very much, ma'am, for your invitation and giving the opportunity to share the knowledge with the students. I'm really thankful to the director, HOD sir, and Dr. Ruchi as well. So I will start with my presentation. I will share the screen. Okay. Is it visible? Everything is
Yes, sir.
okay. So I will stop the video so that we can have good bandwidth for the audio. If maybe some student will face problem. So very good afternoon to everyone.
Good afternoon, sir.
So today we are going to discuss, the title of this talk is Privacy Issues in Internet of Things. The Internet of Things is nowadays very popular. Although it's not a new technology, it has started maybe 20 years back. But nowadays everything is going to be connected with the internet. So today we will be addressing a very specific issue, which is the privacy issues. So in the privacy issue, we will be discussing, first of all, to introduce the topic to our student and the audience. I will have certain things as a basics for Internet of Things. Then I will introduce the Internet of Everything, how gradually we moved from Internet of Things to Internet of Everything. And now itself it is becoming a very big discipline. As sir has said that machine learning is also coming in the picture, data analytics is also coming in the picture. So actually not only these two, there are many disciplines which are coming inside the Internet of Things. So you can say nowadays it is becoming multidisciplinary, because if you talk about industrial IoT, industrial Internet of Things, or you talk about smart grids, so you can see that the things which are from the electrical engineering, which the things which are from civil engineering, those things are also becoming the part of IoT. That's why the new terminology is Internet of Everything. Then we will talk about integration issues, or the integration, how we are going to integrate, what are the platforms for the integration. Then we will talk about the privacy issues and the security issues, which are our concern here nowadays. We will talk about certain methods like how we can anonymize the data, how we can make it similar so that nobody can access, nobody can interpret any meaning out of the data. So that's one upcoming research area. People are working in this area. And finally, we will conclude our talk. So this is a formal definition for Internet of Things, and which is very simple definition also. So any kind of physical devices here we are referring. We are not talking about that those devices should be only the electronic devices, or the devices will be only the computing devices. It could be any physical devices which is going to communicate with each other. So if they are going to communicate with each other, they form a network. And that networking concept is your Internet of Things. For example, if suppose you have household items in your home and you are making a network of all the home appliances, let's say for refrigerator, for the television, for any other home utility devices. So that will form a interconnectivity between these devices, and that becomes your Internet of Things. So formally, how do we define this? If you see, the Internet of Things is the internetworking of physical devices. Sometimes they are also referred as connected. Nowadays, you will find out many research papers or many things. You will notice this word, connected devices. So connected devices or Internet of Thing or physical devices, they are same. And they are supposed to be smart. As you know that it is not like it don't have any intelligence. These devices are smart devices. They can react, they can take the decision, right? So they are connected as well as they are smart. For example, there could be the connectivity between the two vehicles, like vehicle to vehicle communications, like we do in the VANET. But nowadays, that particular area is also called Internet of Vehicles, IOV. The connectivity between the building information, like maybe the environmental information, it is sensing from the outside the sensors, and then accordingly it is adjusting the home utility appliances or maybe any other appliances which require the external input. For example, the air conditioner itself, the sensing the temperature from the outside, humidity sensing from the outside the environment, and accordingly adjusting those sensors to operate in a comfortable manner. So there is actually unlimited number of examples where we can have the interconnectivity between the devices. You see in the many electronic software like sensors, actuators, and any other network connectivity that will enable the ability to collect and exchange the data. So you have two systems, two physical devices. When these two devices are going to exchange the data, and the data is available, or you can say they are somehow connected with the internet, it forms a IoT. So depending on the application, the requirement, you can design your Internet of Things applications just by putting small sensors, the microcontroller which are going to communicate with the device, and they are going to upload the data to the server. Here we are going to just see a few figures. It is about 2020, so it's an estimated figure, like how many devices we are going to see. Already it is connected. 20.4 billion devices, they are connected worldwide. It was an prediction, but it is actually, the figure is also around by 2020. It was 19.4 or 8. The devices were connecting. So this was forecast in 2017 that in 2022 we will have 20 billion devices which will be connected with the internet, and this has become true. So you can understand the complexity, the scope for doing development and the research in this area. And it is not only talking about the, you can say, only connecting few electronic items. No, the business process is also going to change. The business process is also going to incorporate the Internet of Things into to make it more profitable, to make it more interactive with the customer, to understand their behavior. For example, if you talk about like Walmart, so you can see that all the items, they are tagged with the RFID, and the RFIDs, they are connected with the web servers, and all the information, it is available on the internet. So you can assume just how this particular area is growing, how much scope is there for data analytics, machine learning, the security issues. Okay, this thing we can see graphically also. There you can see in the red lines, this line is about the IoT devices. This is an prediction by 2013, 14, 15 up to 2020, how the devices are growing, how the number of devices they are generating, the amount of data, which is, if you compare with traditional computers or computing environment, you will see this line is going not exponentially, but it is going to be a straight line. So that means the data which we are generating from personal computers, mobile phones, or any other personal devices, or even in the business devices, they are linear. But if you see the data being generated from these devices, it is going to be exponentially. So there are many challenges how we are going to solve the issues of huge data generation, huge scope for data analytics, how we are going to drive the business intelligence out of these devices. So these kind of things you will find out in the IoT. To be precisely understand, because sometimes people get confused with the embedded system, IoT, and the intelligent environment. So this will make things very clear. We can see that here the inner circle is a embedded system. So you have to understand that if you want to control any kind of device, any kind of physical device, you need a embedded system, a microcontroller, sensor, actuators. Without that, you cannot control any physical device of real world. For example, if you have even the you have lift or elevators, you have refrigerators, any kind of device you take. If you want to control it, you want to make it functional as a automated system, you should have a microcontroller device, you should have some kind of sensors, or you may require actuators also. So these are the backbone of IoT in order to get it connected with other systems. So these devices, like you have seen, you know very well, in the vehicles we have ABS system, auto lock braking system. So auto lock braking system is an example for embedded system, that when you press the brake in a certain amount of time, it has to lock the wheels. And it is completely an example for real-time embedded system, not only the embedded, but it is a kind of real-time embedded system. So the lowest layer of any Internet of Things is our embedded system. This is one. The second is network embedded system. What we understand by network embedded system. So when it's very straightforward, when we are doing the networking of two embedded system, we can say yes, it is a network embedded system. It has even if you take nowadays any vehicles, it is fully loaded with many microcontrollers. Maybe hundred of microcontrollers are there in any car. and they are connected with each other. So they form a network of embedded system. So that is your, I would say, the second layer. The third layer is CPS. You have heard a lot about this system, cyber physical system. So cyber physical system is the collection of these two. You have embedded system, you having the networking of embedded system. That will form you a cyber physical system. And of course, we are talking about these devices, they are going to interface with the real world, and definitely they will have certain level of intelligence inside these algorithms which we are implementing in the embedded system. On the top of it, you will see intelligent environment spaces. When we are referring to intelligent environment, smart spaces, that means we are here talking about particularly the things which devices are going to learn from the environment. Maybe they could use ambient intelligence to acquire the data, to sense the data, and thereafter training the data for a particular objective, learning the new things, and accordingly behaving it. So if you are training your embedded system, connected embedded system in an intelligent manner, which can sense the environment, which can interact with the environment, even when the event is unknown. So automatically it can take the decision from those unknown type of events. Then we call it intelligent environment smart spaces, or you can say simply the devices also. So if you have anything, these all features in any device, like this we talk about the lowest layer 1, 2, 3 and 4. If these all 1 to 4 are available at one place collectively, we call it Internet of Things. So this was an architectural perspective, like how the Internet of Things are composed, what are the various components that are attached with the Internet of Things. From this picture, we can understand when we are talking about CPS, Cyber Physical System, we can see here also what are the components of any CPS system. If you want to precisely see this thing, you can see here in this triangle, communication, computations, and the control. So any CPS system having three dimensions, you can say, like you have sensor, actuator, you have certain information system, certain kind of integration among these components. And this is a kind of, you can say, layered architecture. Features also you can say that any CPS system is a interdependent system. It is a distributed system because every node can take, every device can take his own decision. They can perform the computations. They are autonomous system, autonomy in taking the decisions. They are not dependent on the other devices. Scalable. Of course, if you increase the number of devices, the performance should increase proportionally. So they are scalable also. You can keep on attaching the devices. It is not like that they are fixed. It is scalable. They should be secure, of course, because they are going to interact with the real world. So security should be there. Heterogeneous in the term of many things, not only in the term of architecture, but also you can say in the term of software protocols, the databases, because different IoT system have a different platform. Still, actually, there is no common IoT platform. There are no common IoT devices. Everybody is developing his own custom solutions. Every company having its own hardware devices. They having they having the hardware and the protocols which are different with each other. But if you want to work with a complete system, somehow you have to integrate. You integrate it in a custom manner because still there is no standard. So this is one of the nature for CPS system. If you have a look on this side, you will find out every IoT devices, as you know, that they are tiny, very small. Their computational power is very limited. So if their computational power is limited, they can only perform not the large task, but very small tasks which are essential to do it. Second, most of the IoT devices you put in the field and they operate just on battery. They don't operate with the power source, online power source. So most of the IoT devices, they are dependent on the batteries, and the battery lasts maybe for 4 years, 5 years, sometime 10 years also. So the battery life will last for 10 years when it will be energy efficient. So all the things should be energy efficient. Means whatever the algorithms you are putting, the algorithm should be very efficient so that it will consume very less battery, and you can have a long battery life. The second is adaptable. They should be able to adapt to the environment. Any changes if you make or they sense from the environment, they should be able to adopt it. So that is another nature, or you can say the feature of any CPS system. Then we have a reactive. Reactive means when we are giving any kind of input to the system or any kind of changes the system experience. So at that time, it should be reactive, giving the response immediately, giving the reactions immediately, because most of the things they will be in the real time system. Then we have another feature which is your robustness. Robustness, we are dealing with the kind of errors which are coming, the recovery from the errors. If there is a bug, there is a failure, it should be able to recover it in a short period of time. Another we have feature that is called maintainable. Maintainable refers, let's say, how much you need the maintenance for any device. If you have any device that requires very less maintenance, like first you install the device and that's it. Maybe after 3-4 years you need to do certain kind of maintenance, then it's a good device. And if you are doing the maintenance every month, you will not feel that it's a good device. Sustainable having many meanings. It could be the economical sustainable, it could be the technological. So sustainable is something which can survive in the environment due to many factors. Could be the technological factor, could be the economical factor, could be the social factors also. So it depends actually on the type of applications. Just to give a broader picture, here we can have a look. For example, you can see here many things are here in the IoT system in a hyper connected society. Like the manufacturing industry, it's all now going to be well connected with the Internet of Things. You might have heard Industry 2, Industry 3, 4. Nowadays, it is Industry 5 standards. So, industries are also now becoming smart industries. All the manufacturing process, they are becoming smart. They are becoming autonomous and smart, and they are well connected with the internet. All the equipments in any manufacturing units, they are now able to talk with the internet. In a similar manner, the health industry is the biggest sector for IoT. All the wearable sensors you have heard, might have seen also. The wearable sensor itself is an example for IoT. They are well connected with the human body, and sometime you might have heard this term, body area network, BAN. So these wearable sensors, they make the network of all the body sensors equipped on the patient to monitor the health condition. So you are sitting at home and all the health conditions, they are monitored at the home and transmitted to the hospitals so that appropriate actions can be taken if there is an issue with the patient. Mobility, the biggest example for IoT mobility is nowadays we call it Internet of Vehicles, in which all the vehicles are connected with each other. They are able to monitor the traffic conditions. They are able to communicate if any critical event takes place. For example, some accident took place, then in that case they will be able to transfer all the information to the other vehicles. So now vehicles are becoming smart. Robotics is one of the, you can say, underlying backbone for manufacturing technology. It was primarily, but nowadays it is very common. Robot is not only with the manufacturing unit, but robot could be at your home also. So many models have been already built for robotics to assist the human throughout their routines also, at the offices, at the manufacturing places also. So these are the wider applications. This side you can see the logistics, the smart buildings, and the smart energy like power grids, smart grids. Now in this picture you can notice one thing. These all, like, it is representing smart manufacturing, the healthcare, the mobility, smart grid, airlines, aviation, many more things. This is okay. Now everything is connected with Google. This is something you can notice here. It is connected with internet, but also it is connected with Google. So that means the major companies like Google, Microsoft, IBM, they having platform, they having the platform to connect all these at one place in order to do the business intelligence. You know, the BI. So business intelligence will provide the decision makers the right fact and figures so that they can take the decision to make the business more profitable. Okay, this is what we have discussed before also. Internet of everything. The new terminologies you will heard everywhere. So it's all variation of IoT only. For example, Internet of Lightning, Internet of Energy, So you should not get confused that Internet of Energy is IoT or not. Yes, it is an application of IoT. IoT is a broader term, and these things what you see, it is an application of IoT. This we have already seen. We have physical objects which is connected with embedded system. Some backend system services you will have for storing the data and processing the network connectivity between these devices and these cyber physical capabilities to make the decision or perform some intelligence out of that data. Now we move towards the integration, what we understand by IoT integration. This is a very hot topic in the industry, also in the academia, research, everywhere. As I told you that Internet of Things devices, still there is no standard. When we are saying the standard, we mean that all the devices follow the same protocol in order to communicate with each other. So IoT still do not have that standard because everybody evolved with their own solution. For example, if tomorrow you develop any Internet of Things, you will have any custom solutions. Therefore, integration becomes a very important issue in the context of IoT. Now, to understand this picture, we need to see here. You can see on the downside, this is all physical devices. These physical devices, they are connected with certain kind of applications. There are many applications available through which you can directly connect your Internet of devices. For example, if you are using IBM platform, so IBM platform has many applications for Internet of Things. In a similar way, ThinkMagic, they also having many applications. So if you bring your hardware and if you connect the hardware with those IoT applications which are connected with the platforms, then you can develop a or you can integrate with the other services like maybe cloud services or maybe the big data analytics services kind of things. So from the device, you are preparing your applications. So all the data generated from these devices, they will go to applications. The application in turn will, it will process maybe certain things it will not require, so it will maybe clean it. So certain things which are required, which are important, will be decided over here in the application, and this application will be connected with the IoT platform. Let's say if you are using the IBM platform, so you have the Watson. In the Watson, you have many services. Entire data you can put on the cloud. Later on, you can use the tool like big data analytics tools. There are many tools in the platform. You can make the decisions. There are many other IoT data services which you can transmit to other platform also. So there are two things. You can divide like this. One is IoT application which you develop actually for your own requirement. The second is IoT platform. The IoT platform, let's say if you are going to develop a end-to-end solution, then you need cloud services. You can do it, but it will be very difficult to upload the data on the server if you don't have any cloud services. It will be difficult to manage it because you need to manually code the things to transmit the data. You need to work on the protocols, then you need to send the packets. But if you are using any IoT platform, in that case, you have to directly connect and it will take care of all the complex stuff. So that will save the time. So this is what nowadays it is happening. So there are 3 4 popular platform nowadays which are available in the market, but those platform are not for every hardware devices. That you should keep in mind, that all the devices cannot be connected with the platform. So these providers like IBM, ThinkMagic, Facility, all these, they will provide the list of devices which you can use with their platform. So you have to be very specific when you are going to use this platform. Now I'm coming to, this was a little background about the IoT. Now, how the privacy and security becomes a concern in the IoT. So as you understand about what is the privacy, so in the privacy is about to retaining the ability to disclose the data consensually and with the expectations about the context and the scope of sharing. So this is an just formal definition for the privacy. For example, like you are using any social media or any software you are downloading, so the very first thing is you have to agree with their uh, privacy policies, and you accept it generally. You don't go and read it because you want to use the software or the application. If you don't accept that, you may not be able to install it. So we ignore it actually. Like in the WhatsApp or in any other social media softwares, applications, we accept actually. So when we are accepting, we are on the risk of privacy breach. We don't know because we have given the access to the data. The data of entire device, we have given the access, right? So we don't know what the provider is going to play with my data. You can think, okay, you are a person, what he will do with my data? But no, he can use the data for any purpose. So nowadays, because everything is going to be connected, everything is going to be connected with the internet. So the concern comes about the privacy. You can say that, you can argue that, okay, my data will be encrypted. It will be stored at a secure place. So if my data is encrypted, my privacy is there. So this could be the case, but if somebody is able to decrypt the data, what will happen? So the decryption of data, then you will have the private information. This is one scenario. Another scenario will find out that many of the data is, you agree that data will be published. You will have no objection if it is going to publish the data or it is going to perform some kind of business intelligence on that data. You will have no objection. For example, you see that all the application whatever you install, most of the applications, they having the advertisement model on that. So based on user preference, based on the user data behavior, his browsing behavior, they do the analytics and based on analytics, they recommend something. So these recommender system itself is a breach for privacy. Any recommender system, whatever you have, suppose you are watching anything on Netflix, on YouTube, and suddenly another recommendation is coming to you to watch or play with it. So what is that? How they came to know that what kind of things you like? So your liking is a breach of privacy itself. So that's why this area is becoming very hot, especially not security, especially with the privacy. With online privacy, we wish to ensure that our personal data is not disclosed to the third party without their knowledge and consent. So we would like to ensure that whatever data we have submitted, that data will not be disclosed without our knowledge. As with any online services, the IoT privacy and the IoT security, they are linked and complement each other. As I said, your data is secure if it is encrypted, but what if they decrypt, then it is not private. The second kind of privacy is risk is here. Entering the password via an unsecured device risk could lead to the stealing of your password, your identity. Suppose you are entering the password with a unsecured IoT device, then also there are probability that your personal information will be stolen. As we said earlier also that whatever the application we are installing, they insist that your device will be accessed. They will access your phone log, they will access your directory. So there is no privacy at all. Impact of cybersecurity issue, why we are talking about this, will if you go through the many events which had happened in the past with the live devices, with the live system, you will find many examples. The planes were hijacked, the devices, the air traffic controllers were hacked. So many examples you will find out on the internet, and that has a significant impact to rethink about security issues in the cyberspace. Even you will see that many of the products which are coming in the market, the data is being transmitted to somewhere else. It is not transmitted to your secure server, and people are not bothered about where my data is going, right? They just bother about the facilities. Okay, it has been provided, so they are using it happily. Even if you take the example of any CCTV system, you take whether it is Samsung or whether it is Hikvision or whether it is Honeywell, everyone having their servers in some other country, and data surveillance data is flowing. That is also a big concern about the privacy. So what risk do insecure the IoT devices being brings to the privacy and the security? You can see that an example it is giving a smart camera using default username and the password combination could be used to spy on your or to be compromised to send junk information on the internet. For example, the baby monitors, the CCTV at your home, most of them use the default things, and data is transmitted through unsecured channels. That's also an questions about the privacy. The wearable smart devices. For example, they send the health information over unencrypted channels, can expose the personal data. Because when these devices were developed, actually security aspect was not thought in that manner, what is happening today. So even though most of these devices, they are still using the data transmission without any encryption. A smart home device like a television that lacks sufficient updates can be vulnerable to new attacks, and that can be used to share the private data. Smart vehicles running over insecure software can access remotely and compromise to disable certain functions of the car. Many event has taken in the past in America that the devices, not devices, these cars were hacked. These smart cars, they were hacked. They were stolen even because they were fully smart and the privacy was breached, the security was weak. How can IoT be improved? The security of IoT, how we can do the improvement in that. So it's saying that if you have the best practices among the vendors, manufacturer, on the security breach, what they have the experience. Based on those experience, like what kind of attack has been done in the past, what are the security loopholes, a good solution can be developed. Because every device has its own protocols to function. So maybe one security protocol you cannot directly apply on the every device. So you may need many kind of security algorithm. You need to collaborate with each of the vendors. Also, you need to train the users. You should develop some kind of training to identify the insecure devices and how you can tell them that this is insecure. You can also use two-factor authentication for these devices. Now, this I'm just going to point towards another approach, which is now it is becoming popular. How we can anonymize the data. Anonymity can be achieved in what manner? For example, if my data, I do not make it actually private, let's say it is public, but it is presented in such manner that any person cannot identify that it's my data, then there is no question about the privacy. If I present a data which you cannot find out any information out of that, that means my data will be of no use. So that approach is called anonymity. Anonymity deals with anonymize the data in such a manner that all the data is mixed. You cannot identify a individual by looking at the data or even by performing the any kind of data analytics. Nowadays, you know very well that we have a lot of tracking applications, even though you have like Google Map. So whenever you use any location services, the Google itself it is aware about you. It is aware about your behavior also, which place you are going, what kind of restaurant you are going, what kind of club you are going, where is your office, where is your home. Everything is known to the Google or any provider who is to you are using that location services. So we should think about some methods where we can preserve the privacy. So my data will be shared, fine, no issues. I will disclose my private data. For example, let's say I disclose my social security number or national ID. I will disclose my name, everything. but in certain restricted manner, so that I will not be identified. So privacy preserving data sharing, the need to share the data for research purpose. Now you can say why the companies wants your private data, why your social media needs your private data, why they force you to agree with their term and conditions, because you are using that software for free, but nothing is free. So what they will do, from that data they will do the marketing analysis, they do the decision making, they identify the trends in the customer behavior or the user behavior. Accordingly, they will devise the business strategy to the businessman so that they can sell their product. So it is all about selling the product and making the profit, and for that they need your private data. I will just quickly, I will take this as an example so that at least you will have a flavor for understanding this entire area. For example, let's say this is giving certain data that 87% of US population, and this is a true data, 87% of US population uniquely identifiable by 5-digit zip codes. Gender, date of birth. If you know the zip code, gender and date of birth, the population or individual can be identified. Why? This is a big question, and you have to understand how. For example, there are two data sets. One is your medical data, another is your voter list. So in the voter list, this all information is available, and this information is publicly available. It is not like it is private. This information is available publicly. Suppose you are assuming that your medical data is private, like ethnicity, visit date, diagnosis, what procedure was performed, what medication has been given, what is the total charge, which area you belong, what is the zip code, what is the birth date, age, date, gender, etc. So if you have two data, one is your prior knowledge, that is your voter list. If you do the intersection on these things, the gender, date, birth, zip code. If you do the intersection, you can easily find out who is that person. Because this data is available publicly, and this data somehow you have got it. You can say the hacker has retrieved the data from the hospital, and it will match this data with voter list. Intersect on these identifiers which are available at both the places. Easily you can find out all this information. You can find out what is the name of the patient, what is the address of the patient, everything, just based on these few parameters. Okay, so these parameters, what we are common, we call it quasi-identifiers. So these identifiers like zip code, gender, they are quasi-attributes. These attributes should be protected for linking attack. Means zip code, gender and the date of birth. This combination is very dangerous. So this combination you have to somehow protect. using any method to avoid the linking attack. So if there is any kind of linking attack, it will not be able to get his personal information if this information has been prepared in such a manner that matching is not possible. So precisely, there are many algorithms, but there is one algorithm called K-anonymity that was proposed in 2001, and it is one of the basic and most fundamental algorithms which you can use, you can extend, you can improve it, still having certain drawbacks. So in this one, each record must be indistinguishable with k minus 1 other records with respect to the quasi-identifier. So I will not go here in more detail, but we can just understand by example that we have two, this is my original table, this is your, you can say the medical data, okay, the patient records. The patient records have zip code, age, and the disease. Assume that you have retrieved or the hacker has retrieved this data from some medical repository, okay, and you have a prior information as we have seen in the previous one, because we have the quasi one, so you can find out what is the name of the patient, what is the address of the patient, right? So how to avoid them? So in the previous definition we have seen that at least there should be k minus 1 other records that should look similar to the that record. Now here you can see this particular record, this particular, and this particular. So there are 3 records. The zip code is 476 star star 2 star then 2 star. Now can you identify this record belongs to whom? We cannot, because whenever the attacker will find out this data, he will get a relation from, let's say from voter list, there is one record, but this side it is 1 to M. So does this is the patient, or this is the patient, or this is the patient? It is very difficult to find out, because for one public or prior art information you have 3 records. In a similar way, you can see here also. Here also you cannot find out any kind of information. The attacker cannot find out to whom it belongs. So we have 3 similar records. So the K factor, it decides how many similarity is there. In this one we have 3 similarity. If it is 2 similarity, then it will be K. So actually it depends on your application that what exactly you want to try, you want to develop. You can use appropriate threshold for the K so that information is also not lost, and you can also preserve the records. This is another example. This was the actual table you can see here. This is your actual table which having the zip code, age, and this gender, and this is your generalized table. Keep in mind this thing that these star are not only the masking what you see in the password. This star, this grouping has been done with algorithm, tree-based algorithm, so that you can join into one. It is not only that you are why you are putting here star. No, this star is coming the aggregation from the bottom. So this is what we have here discussed. To achieve the K anonymity, we uses the generalization method and the suppression methods. So in the generalization, we have replaced with less specific values, like the age was, let's say, even we can do like this also. If age is 20, we can write it, we can develop a algorithm, the age 20 to 30. Instead of telling the actual age, you can just tell 20 to 30. So now the data is anonymized. So instead of a specific value, we have provided the range. So there are many algorithms to do this thing, and mostly they are based on KD tree or tree algorithm. So this is called generalization. Suppression is that you remove something like it was 29, so you put it to star. So one digit you have suppressed using your K anonymity algorithm. So this is a basic overview. You can develop your own algorithms also based on that. Here you can see how they are going to suppress here. For example, this is your age 29, 22, 27. So all 20 to 30 they have been suppressed into 2 star like this. The zip code also you can see here. Certain range like 677, 602, 678, all they have been suppressed in this range. Means these 2 digits they have been suppressed. So nowadays it is becoming very hot topic about in the IoT to preserve the privacy. And there are many other, location based, as I discussed, location based services and the privacy issues. And this should be taken care. For example, any tracking application, even for the children who are going to the school. Nowadays, you know that it is all being tracked by their application. So tracking of the individual is a really serious concern in this area. Okay, so this is another example for location-based privacy, how we can, provide the privacy in the locations. This is just an example that you are moving from one place to another place. Every information is anonymized by algorithms, anonymizing algorithm. They are stored in location-based services. So even if the background knowledge attacker has, he cannot do anything, because you can see this location has been converted or anonymized with certain other data. It is not exact. Maybe in the database they have latitude and longitude, but now they have been referenced with certain identifiers. So these kind of things actually are very new in the location based or in IoT devices, that one must, as a student or as a researcher, you can find out a scope for doing the research in this area. So this is my conclusion about this all talk. So my objective was just to give a flavor those who are not aware about Internet of Things privacy issues. So privacy has become a serious concern in upcoming days of IoT. Preservation and diversity algorithm will help for data protection. The standards, like we discussed, we should be interoperable devices in IoT, and that there is a need to develop the standards also. More improvement in the algorithm is needed for doing any kind of research. Also, we don't have policy and regulation yet that need to be formed. The framework and the best practices shall be adopted. So this is all about my talk. I am finished. So I would like to take any question from the students. If you have, I'll be happy to answer you.
Thank you so much, sir.
Welcome, ma'am.
It was indeed an informative and enlightening session for all of us.
Thank you, ma'am. Thank you. Any questions from the audience if they have, especially the students, if they want to ask anything?
Sir, I guess no questions are there. Shall we move on, sir?
Yeah. Thank you so much, sir. Ayub sir, thank you so much.
Thank you so much, sir. Ayub sir, really, it's a very wonderful session.
Very nice session, sir.
Thank you, sir. Thank you very much, ma'am.
I would now introduce you all to our second speaker, Dr. Shruti Kohli. She is a PhD in computer science, having a vast experience of academia, research and industry. She is working as a lead data scientist in DWP Digital, UK, leading on innovation for the Innovation Lab. In her current role, her key responsibility is do horizon scanning and lead data and tech innovations that would support the department in improving their services. Before her current role, has more than a decade of experience working in the private and public sectors. Previously, she was working as a lead researcher in an area of big data analytics, Birmingham Center for Railway Research and Education, IoT sensor data for mining health of rail assets. She has many publications in national and international journals and has presented the paper at international conferences. Ma'am, I request you to start the session.
Thanks a lot, Apurva. Hope you all can see my screen, right?
Yes, ma'am.
Yeah, great. So first of all, I will say thank you to the Jagannath Institute for calling me. I'm really thrilled to be here. I really like the topic of this particular workshop because it is very close to my heart. My journey before, I know Apurva has told about my background, but still all the youngsters, I want to say that when and how I got connected to machine learning. It's more about a decade back when I was doing my PhD, when I was on Google trying to research what other people are doing. At that point, I wanted to understand more like how this Google is working, how these machine learning algorithms are working, and that was the point where that was my first exposure to machine learning, and then it was no looking back. And I have spent more than a decade over there, and hopping between private, public sector, academia, still connected to the roots, as research is something I really always want to do. So today, the topic that I've chosen is trending applications of machine learning. So I have chosen this topic just to give you all the exposure of what exactly machine learning can do and what exactly, how exactly it is bringing difference in the lives of people, all of us actually. Maybe some of these applications that I speak about already you are aware of them. But yeah, it will be good to see it from a tech angle, trying to understand how they are working and what are the algorithms behind that. Sorry, my system just hung. So let's, without any further ado, let's talk about the agenda for the day. What I will do is I will be talking about the machine learning process, what exactly it is, how it is different from AI, little touching upon how exactly these algorithm works, and then we will touch base on trying to understand how it is creating the innovations in content modernization, cybersecurity, healthcare, and your customer service. So before we kickstart and speak about machine learning, it is very important to understand how they are different from artificial intelligence, or other buzzwords that you keep on hearing. And you will see a lot of startups that are coming with .ai and how exactly, what are they doing and how it is different. So what is artificial intelligence? So when we if we try to come with a theoretical definition, we can say it is ability of a computer or a machine to think and work like a human, who is so that the machines are able to make some intelligent decisions. And a subset of that is machine learning, where it is more about how a system can learn through the experience with the data and try to understand and do some kind of classification or prediction for us. So if we say AI, it will be like something that can help you to take that will take a decision for you, and machine learning can help you to take a decision, and that's the way it bubble grows. And deep learning is something which is like a more complex set of machine learning algorithms, which are more unsupervised learning. I will touch base them as I will move forward. So let us try to understand what exactly is machine learning. So whenever you really want to, so when you really want to understand what we can do, if you ask any question, if you have any question, for example, is this image a apple or not, a very simple question, and you have got a lot of images and you want to see, can we do it using a machine? And you can really come up with you can use a very simple classification algorithm where you can insert a couple of images of apple. The model will understand, okay, what is an apple, what are the features of the apple, and on the basis of that, when you insert another image, and you can test over there whether your model is able to identify it is an apple or not. So first of all, it is very important that you have got a question in your mind, and for that question is a very you just make it very bit size, so that you can get an answer like yes or no, or one quantified figure, like predicting the house prices. When you get that to that level, and then the second step is to collect as much data as possible for that particular to answer that particular question. And this is the key for running a machine learning algorithm, that you need to have the data around it. For if you are not able to get that particular data right, then the model is not going to work. Because what is a model? These are mathematical algorithms which have just been programmed. So then you train your model on the basis of that particular data, and then test using a new image. For example, I took a pear, and then if the machine learning algorithm is not able to identify that, then you have to go back and see what was the problem, if the data was or not enough, or the model's parameters were not properly tuned. And this is like an iterative process through which you have to iterate. So I will say this is to understand in the way of Chatur Ramalingam. If you all have seen Three Idiots, that's the theoretical way to understand it. And I believe this is the Rancho's way, where you just see that we have got a bunch of mathematical algorithms ready for you to use. You just keep on steering the data. If you feel it is right, it's fine. As you steer the data more, try to see what are the gaps, and you keep on doing it until you get the right outcome. So now let's do some deep dive in machine learning algorithms. So it is, as I said, it is a branch of artificial intelligence. And let me tell you by an example how it differs. You must have seen the Google Assistant video of scheduling appointment for a haircut, that Sundar Pichai launched, and it was really viral, where a particular, your chatbot is trying to book an appointment for your haircut. That is something we will say is like something making a decision for you, that is AI. And when we are talking about Netflix, where something is helping you to recommend what is the video, what movie you should watch. That is your machine learning algorithm. So as I said before, this is very important that ML systems can learn and improve only with the data. So when you are having a lot of data, that will really improve the experience of the model, and then only you can work and use them for your purpose. So this is the Google Assistant. I hope you have all seen. Like, I really found this particular video very interesting, and if you have not seen, just Google it, and you will find how this bot is making these decisions. And this is the example of Netflix I gave. And not only Netflix, even if you will see that your YouTube is very smart. Whenever you are trying to you want to see something, it recommends some videos for you. And similarly, when you go to Amazon and you buy something, it says if the people who bought this also bought this. So there is a use of like near KNN, the nearest neighborhood algorithm of machine learning, that could be used at the background. So this is what I wanted to. I really wanted you all to, out of this session, see how you can relate these machine learning algorithms working around you, making your life easier, so that next time when you see something like this happening, you could see, like, okay, this was a KNN algorithm. This was a classification. This could be a classification algorithm that is bringing this particular, that is working in the background. So before I just touch base on the trending applications, it's very important to understand some of the basic algorithms in machine learning. So we broadly classify them into two parts: supervised learning and unsupervised learning. So supervised learning is as you means that this particular algorithm needs lots and lots of historical data on the basis of which the model is trained. So you will say that you are saying from the start that the data is required, but here we really feel that we have got the data and we have got the label set. For example, I will have a lot of images of apple and we will label them that this is an apple, this is not an apple, pear, mango, and this is the kind of data set we are going to feed into the system, and that will be used that could be used for training that particular model. So when we already have got this label set, it could be any guy. I've just taken an example of Apple, but if we go wider in cybersecurity, it could be that this particular the person who really, for example, if on the basis of event, if someone is logging on in the evening, at night, uploading some file, that was a fraudulent activity. So if we have got some history and we are able to label that as fraudulent, non-fraudulent, we can use, we call that supervised learning, because we already have got a bunch of use cases which we are feeding to the model, and that's helping the model to train itself. And in case of, and as I said, like, classification is the simplest one. If in case you really want to try out these algorithms, I would really recommend going with classification, because it will be like, okay, the ball is red or white, or the simple kind of mathematic examples that we do on the blackboard, we can try doing it on using this particular algorithm, and it's quick and easy. And the second one that I will recommend is regression, which is actively used for any kind of prediction of weather, or prediction of your trading, stock market. Because if here what we try to see is, we have got a dependent variable, that is, for example, stock price, and what are the other variables on which this particular variable is dependent, and on basis of that it is calculated. I won't go in the detail, but yeah, these are some kick-starting algorithms that you can try. So then what is unsupervised learning? For example, for some kind of activities, you are having the data and you can label it. For example, through the features of human being, you can label them. Okay, they are from Asia, they are from China, or they are from UK, or you can do that. But there are many times you are not able to have that particular features in advance, and then you really want to see what the machine learning algorithm finds out. In that case, we call it unsupervised learning, where we throw lots and lots. When I'm saying lots and lots, it will really work if we have got really lots of data, and where we just put in some algorithm. Clustering is something which is one of my favorites. And that particular algorithm tries to understand and try to group on some particular patterns, and we get some clusters, and then looking at those clusters we can really understand why these people are behaving together. And this is this is used exhaustively in marketing research, where they just want to see patterns of people, what they are buying, what are the kind of stuff that is just left in the cart, never bought. So these kind of where we are not confident, we can't label stuff, but really we want to see what are the patterns, how the things are getting grouped together. These are the kind of areas where we go for unsupervised learning. So I won't go in the detail, but yeah, this is something I touched base. Here is the classification which tells about whether the particular flower petal is setosa or not. But yeah, this is important just to understand from if you really want to become a data scientist or an analyst, this is the slide that is for you. As I said, you have to define the objectives, you have to prepare the data. I will just ignore the other boxes about normalization, transformation. These are about how we are preparing the data. The important thing to understand is that whenever someone deep dives in this field of data science or data analytics, we really feel like we will have a bunch of data, we will have some algorithm, and our key work is to join them together, and just putting the data in the model and it will work. But it doesn't work in that way. This means that we have to work a lot on the data. The data may be of different shapes. For example, if you're talking about some demographic data, the data may contain ages of people, and the data may contain weights of people, or it may contain income of people. So these are different ways in which the data are read. So how we normalize them to the same level, how we transform them, and how we make it fit for the modeling, for machine learning, that is a very, very important aspect. And a lot of work, effort, energy goes in this part. My experience in data science says that about 70% time the data scientist is going to spend in data. The time is spent in how this data is being collected. Does the data contain any bias? What are the features in the data? When I'm saying features, what are the particular fields, how these fields are there in the data, how they are impacting the data? Is there any kind of correlation in the data? Correlation in the data means that there is a literal dependencies between the data. That is, the fields among themselves that may cause some kind of bias in the results. So 70% of the time we spend on that's data engineering. We call it data engineering, like a subset of data science. And once this data is prepared, then the job becomes better and easier, where you just put it on, you just put that particular data. In the simple way, I will say, you connect that particular CSV file to your Python notebook, having that algorithm, you run it, you see, are you able to get the right predictions, right classifications? And if you're not able to get, you keep on playing with the data until it works for you with some confidence level. Of course, it won't be 100%. It depends on how much confidence level of the result is enough for you. So this is something I have already spoken about, and really, in case if you are interested to go in this particular field, I will really recommend to cash your college time to just pick some some particular coding, whichever is comfortable to you. Maybe it's Python. Python is my favorite, and then just try to play with the data and see how you can transform it. And then I spoke about feature engineering. Let's skip it. It's a little heavy for this session. And then, as I said, the model building. So this is something, when you start building that particular model, it's very important to see that you do a kind of cross validation. The cross validation means, like, what you do is you whatever the data you have, you divide it into say 80-20 or 70-30 ratio into a training set and a testing set, and on that particular training test you train the model, and on that 30% of your data you then feed it to that model as test and try to see are the predictions right, are the classifications right, and you keep on doing it so that you are sure that your model is giving, you are confident with the result of the model under the different scenarios when the data is being changed, right? So as it is written, there is no free lunch. In the sense, you really need to have a very good understanding of the data that you are putting in to run that particular model. But there are many scripts online available. If you go to GitHub, you will find that very basic scripts just that you can just download, and you can just try to run it yourself. Just try to see how exactly these machine learning algorithms are built and run. So now let's move further, and it's important to talk about how these particular innovations are, how machine learning is impacting different areas, as I said. So first of all, let's touch on content moderation. As you all know, like content moderation means what is the content that is being uploaded. It is becoming a very fast growing industry. You must have heard recently, like, some of the tweets that are posted by any leader or any celebrity really creates a lot of outrage. Example is the Trump tweet that was done recently. So how exactly these social platforms on which all of us are hooked in. Facebook is said to be the second most populated country of the world. Maybe it's first now. My stats are outdated, but yeah. So how these Instagram, Twitter, how they can really make sure that the content that people are that the content that people are uploading is not something that will really be like, is abusive, or it can cause cyber aggression or cyberbullying, some kind of hate speeches that, people upload, or doxing. Doxing is like, you follow up someone to create the bad image. And then many times you get some link which says that, you click over here, you have won a lottery or something. It used to come to our email, but it's these kind of content are being spammed online. So how exactly how these social platforms are making sure that, they are able to do this content moderation. So if we talk about the big giants, they have got billions of users, millions of messages, photos, which are posted over here. And therefore, manually, it is not possible for them to inspect. So they are leveraging on the machine learning systems to automatically parse the content that is uploaded on their websites. So before we understand, let's I've already spoken about this content, but it's important to understand what are the kind of content, because on the basis of the content, whether it is abusive content or a fake, misleading content, or scam phishing content, you need to have appropriate kind of databases at the back, the data that will be used to train the models, so that your machine learning model is able to identify that content. So it is very important to understand what could be these particular data sets, these problems are, and what kind of data sets are required for that. So, and what is the outcome that we are expecting from the machine learning model? What we are expecting is either when the user is inputting that particular information and it contains some abusive word, or some very toxic words are over there, it is going to warn the user, and it is possible that it doesn't allow a user to upload it, or at some point it is possible that it automatically flags and the content is sent to the human reviewer who can review it, as I said, it could be like totally AI does deletion of the content automatically, so that it decides that this content should not be there. So how exactly on the basis of these outcomes you can tailor made how you want your model to run. So, and how exactly they are working. So we have got the machine learning algorithms. We can go with the supervised learning algorithms because we have got a lot of training data. We already know what are the phrases, what are the kind of what can cause problems. And as I said, the knowledge base, I have just listed some of the knowledge bases. Bad words, hateful users on Twitter, offensive profane word list. This is some of the bag of words, or the data sets that which are freely available on internet. My favorite website is Kaggle, and Kaggle is a website where the naive data scientists who are starting participate, very seasoned, experienced data scientists participate in the competitions, and where you will find some of these models, some of these notebooks with the scripts run over there, which you can run, and you will find a lot of knowledge base, lot of data sets and resources over there. So in case you really if you really want to try something out, you can go to Kaggle and see over there. And for this particular content moderation, majorly the machine learning algorithms that are used are natural language processing. So what exactly is natural language processing? As the name says, these are the machine learning algorithms that you can use on text data. Right. So, and these are one of my favorites because I used them extensively while I was again doing my PhD and during some of the research projects with a marketing company, where we wanted to see like what are the words, what exactly are the words which really provoke a user to click on a link. So that is a different story. But yeah, here what exactly natural language processing can do is, as it has couple of algorithms like named entity recognition or sentimental analysis. So what exactly is named entity recognition? It will try to identify, okay, whatever the content you are putting in, what are the entities, what are the nouns, what are the pronouns and adjectives, and then it is going to match. For example, your noun is something, or is a proper noun, and it could be a name of a very same famous celebrity or someone, like and that could be matched in some of the knowledge base databases at the back end. Then this means this particular content needs to be understood further, that why a person is writing about that. Or if you're using adjectives which are negative, which are abusive, again we will have some kind of databases at the back end in the knowledge base. For example, the bad words, where it can be compared over there to see why why this negative word has been used. So this is the way you can really tokenize the whole text, the content that is written by the user, and keyword filtering can be done to understand the context in which that particular words are being used. Another very important technique is sentimental analysis. So, it's sentiment analysis. So, as the name suggests, sentiment analysis, it helps to understand the sentiment of the writer. So, whenever you are writing some content, if you write, hi, it's a sunny day. This means it's a sunny is like a positive word, and this means that the sentiment score for your particular content is positive. But if you say it's another bad day, this means what I'm trying to say is that it's a little negative. It may not create a particular some it's not something for moderation, but it is negative. So on the basis of these are very simple examples, but yeah, on the basis of this particular scoring, every content that is uploaded can be given a score. And then when the score is given and it is totally negative and it contains some context to some some celebrities or something. All these particular things can be analyzed together to understand, does this content needs to be skipped or eliminated or not. So that's a very simple way to understand how this content moderation is working. As you all know, picture is picture is better than lots of words. So I hope you will be able to understand what this particular diagram is saying. Let me start from the left. So any of us, we upload our content which could be a text, image, audio, video, and metadata. In the previous slide, I skipped telling about, like, it is not only the text, but also images or audio or video files that are need to be moderated, because we upload freely anything on Facebook, Twitter, as of today. So for image, again, there are algorithms like your object detection algorithm. There's a vast complete industry in your itself that is dedicated to computer vision. So if you are if you have more interest in images, that is something may convince you more to try out machine learning fields. So images are over there, and even you have got your optical OCR, optical character reader, simple tools that were already before, but now they are more like AI or machine learning driven to make them smarter. That could be used. Audio and video, you can use transcripts. Their transcripts can be analyzed, that whatever you are feeding in, again, does contain any words that could be abusive. So once the user has uploaded its content, it directly goes to a particular model. And pre-moderation and post-moderation, we say that these are the two main areas of moderation. Pre-moderation means that it is before the content is uploaded. As I said, as you are uploading, it is going to check. And how it is going to check? It is, again, the Guru Mantra is training data, that we have got enough knowledge bases in the back through which we have trained our models, so that when so that the model is well equipped to identify some basic complex harmful words and context over here. And on the basis of that, the model can label that particular content as harmful, not harmful, or uncertain. So in case the content is found to be harmful, again, this is just one slide that I took from Cambridge Consultant, one of the company who is doing content moderation. But you can really customize it your way. Either you can make your particular model empowered enough to remove the content, or it can come flagging it to you, and you can, as a human moderator, see whether you want this content to be online or not. Right. And in case it is not harmful, but still it happens, as you are posting something online, or if someone posts any comment, there is a link over there which says that if you think the content is harmful, tell us. So that link helps. So this is the way how what we have done is a job which is manually done by humans to moderate the content is being done by the machine learning models and the advanced AI models, so that the content could be moderated. So the next field that I am really interested is in cybersecurity. So what exactly is this field? As you all know, like, it's nothing new. We all are like, being a kid, I had been hearing about having firewalls and that, antiviruses and that on our computers. Before it was desktop, then it came laptop, and now we need these kind of security systems everywhere in our mobiles. We are, as in previous presentation you saw, the IoT sensors, they are being used extensively. So we need to safeguard them through cybersecurity. You must have seen a lot of movies in which it's shown how cybersecurity attacks can really damage a lot of stuff. And so just to visualize, like, that this industry has become bigger and bigger, and how exactly what we want to do. So whenever you try to run a machine learning algorithm, as I said, it's very important to understand what is the outcome that you want to achieve. So either you want to just identify the threat, that okay, this is a kind of threat in the system and you want to flag it, or you want to there are many AI based antivirus software that are in the market that really takes a decision and removes the file. And then some is like user behavior modeling, and again this is my favorite topic because from 10 years I had been working a lot I had been jumping industries, but analyzing the user behavior is something that really interests me. So I will just share quickly about one of the cybersecurity project I did in one of my last jobs, where what my colleague was doing was collecting lots and lots of internal data of the company. What was the internal data? For example, when Mr. A opens his laptop, when it is connected to network, how many people are accessing at the night at very odd times. So the events, the timestamps when people are accessing the network of the company, timestamps when someone is trying to upload the content online, how many times, like the times when the content is being uploaded outside the company and to fishy, like if someone is uploading a lot of content to Gmail, or someone is plugging in a lot of USB. So this was the whole internal intrusion detection kind of data that was collected all over the I think 5-7 hubs that ran in like millions and millions of records. Imagine every timestamp of what we are doing, like it's a footstep that was being used. And also apart from that, we collected browsing data. What are people browsing? And there are many interesting tools in the market. My favorite is Splunk, which helps you to audit them, like go deep dive and query and try to identify where the people are spending a lot of time. It's not more about spying people, but it's more about, the focus is that you have got your own blacklist, whitelist of resources, the way people work, the websites people visit. How can we use that particular list and try to identify whether someone is doing some kind of spamming, or is doing some fishy activity? And that was a very, very good project in which we really tried to identify the patterns, and we were able to identify what are the honeypots in our network. Honeypots, where are exactly the kind of attacks happening, what are the major behavior of people that can make the company prone. And that's the way we tried to close the loops in the security. So that was one of the internal projects, just to understand and how to groom that. But there are lots and lot of company. I will share in the next slide how they are working. So how exactly these cybersecurity companies are working. So again the Guru mantra is, there are two major type of learning, two major type of machine learning algorithms: supervised, unsupervised. So as you know, we are all aware of a lot of attacks. And when we train our model on the basis of those attacks, we can, the malicious behaviors, we can really use them to classify any new action as your a spam activity or not, a threat or not. But the only problem with supervised learning is, like our vision is restricted. We are just looking, and we are only trying to find what we already know. But if we really want to go ahead and try to find out something that we are not aware, because as we will have a lot of ethical hackers from you all who will support, but there are many people who take to these suspicious, so their brain is also growing. So how would we know what are they expecting, what they are coming, what are they going to do? So we have to come up with unsupervised learning. And in unsupervised learning, again, what it will do is it will just try to find outliers in the data. So what do you mean by outliers? And this is the way, in any machine learning algorithm, we identify a different extreme behavior. For example, we all know how a general behavior of humans when they are the day behavior of humans, what they are doing. But if we really find that someone is logging very late in office at 1 a.m. at night or something, that becomes the outlier. That is something is a very different kind of behavior if it is happening very rhythmically. So, and as a humans, we are able to identify this outlier behavior. And similarly, we really want the machine to identify all the outlier behaviors in the network, in the network, in the accessibility, in the way user are browsing. So that will help us to identify what could be the new kind of threat that is coming over there, and what could really that's something that is knowing the unknown, and that is where cybersecurity comes up. And in this one company that I have really seen a lot of demos of their product, and have seen its implementation in one of the previous firms is one of the previous firms I worked is Darktrace, which was a brainchild of a very small number of people, and how they really used the unsupervised learning models, how they developed it to come up with like a black box which you can plug and play, and it is going to tell you a lot of anomalies in your system which you were not aware of. And so that's one of the company. And again, when we talk about machine learning algorithm, it depends upon, we can use any unsupervised, supervised. Again, if you are trying to read from the text and trying to identify the security threat, it could be machine learning. And if it is image, it could be object detection and all. So this is one of my favorite slides, because this really shows me that how cybersecurity company has evolved. So at the time of 2000, when that was the time of Y2K attack, there were around 5 companies which claimed themselves to be cybersecurity expert. In 2010, when I was doing my PhD, I think we heard of 10-15 companies. And now, after a decade, almost a decade, we could see 1,000 companies are there which claim themselves to be cybersecurity expert. And .ai is one of the popular domains that are used by them, that they really claim that that their particular package, their products are AI driven and are very intelligent. So why this has happened, we all know, because we have just moved from just desktops to using internet everywhere. And this particular slide shows you some of the major startups that have come up in IoT security, your sensor security, mobile security. My area of interest is a cloud security, because as you all know, we are moving to most of our data to cloud. I don't remember last time I connected a USB to store my data, even if it is my photos or some kind of other stuff, document data. We are all reliant, and think of the companies, no one wants to have their own infrastructure. And these cloud companies help you to give infrastructure as service, you just pay and they maintain, they make it secure. So they have got these clouds, like the big giants like Amazon, Microsoft, Google, all of them, they have got their partner companies and their own resources that are working on cloud. So this is a particular area of interest, that how they are really changing and how they are growing for supporting this kind of infrastructure. And other one, and threat intelligence, behavioral detection, and network endpoint security is, we all know this was the one kind of secure network threat we used to talk about, on the network. Obviously now internet has grown, so this is also one of the growing area. So I really feel this particular slide can give you a good idea, where are the jobs, where are the people spending, what are the specialization people are doing, and and the ground rule is understand the basic machine learning algorithm. You can choose any field and you will see startups, you will see these growing firms everywhere, and and definitely spectrum of cybersecurity is really growing. So I hope you enjoyed the cybersecurity part. And another one I will briefly touch base is the healthcare, where I really feel that a lot of companies are coming up in healthcare, and a lot of companies are working in three major areas. The three major areas is disease detection and diagnostic, where how exactly the disease is being detected. Like if you have seen in this pandemic time, like lots and lots of predictions, lots of new way of detection and diagnosis are coming up, and how exactly they are making a difference. SigTuple is one of the company that really used to build system that can analyze images of blood. They are really helping a lot. I've really read some of their case studies, and I really like that particular company. Some other companies are like online doc, which uses AI for symptom checking, so that you can do some kind of self diagnosis. Although there are a lot of challenges, but yeah, we can see the company emerging up. Apart from that, there is a lot in process optimization. Process optimization means that hospital industry is not just for patient diagnosis. There's a lot of churning of patients, like a lot of patients leave, new patients come, the bed management, waiting time of patients, like doctor appointment. These are also the area where exactly it is very important for the companies to see how exactly they can make a difference by using machine learning. So that is one of the very interesting field that is coming up. And again, you will see a lots and lots of patient facing applications, where the patients are able to make online bookings, are able to talk to chatbots. Some of them are machine learning enabled, some of them are based on rule based system, but there's a lots and lots of stuff that is going on. And majorly, again, when you are talking about these kind of your developments, data is the key. Like if you see what is the primary data here, it could be the historical patient records, that could be from research institutes, from non-profit organizations, from medical service providers, or it could be the data that has been collected by some in open source. This particular data is available, which talks about the symptoms, or it has been collected from a lot of platforms. So it is very important for us to understand what is the data that is there, and for whatever, wherever you are trying to make a difference through machine learning, you have that particular data or not. And again, training of models, as I said, we can just go without machine learning, some hard coded recommended rules, or we can go with a supervised learning, or unsupervised learning. And there's another field, I won't touch it, reinforcement learning, which is more about robotic actions. And yeah, so I won't touch that particular field, but yeah, that is of interest when you are trying to see how you can create robots to help your arms, that kind of thing. So either these models you can train yourself, or these models are something you can pick up. There are in Google, AWS, your Microsoft, lot of pre-trained models are already there. So you can use that particular models to try and start. I will really recommend some of you, if you really are interested in this, start doing some fundamental certifications, trying to understand how these particular cloud are making a difference, and how they are making the jobs of data scientists easier, so that you don't have to do coding from scratch. Yeah. So next is, I'm not going to go to a deep dive in chatbots, but it is very important to understand that we are dealing with chatbots everywhere. We are we can see that in online e-commerce portals and your websites, we can see a lot of applications of chatbot, and all of the chatbot are not machine learning. It again depends upon if it is a rule-based system, like if then else approach at the back end, but many of them are now being machine learning enabled, where it is very important to understand the context in which a particular person is asking what is the query, and again that is the language processing NLP that is need to be done, and from that particular line that the user is inputting, you can identify what is the intent over there. And when we are saying what is the intent, it means we try to find out the major words, the major words that are the question, and rest are your your pronouns and all. So how we can pick that up, check it in the knowledge base, and try to find out what exactly the person is talking about. So this particular slide gives you a journey which shows how a chatbot is created. So we decide on what intent to answer. This is something I picked from Gartner, one of the website I really use to keep me updated for machine learning. Training the chatbot to recognize those intents, and designing the dialogue and answers that the chatbot can give, and then you integrate it. And as easy it is, like it's you can see it's simple easy step, but I've really found that this is something, is really still a struggling field, a lot of scope. There is a lot of way you can make chatbots, you can plug and play, you can easily make it, but yeah, there is a lot of potential here to contribute, because how we can make chatbots humanly intelligent is something really still being worked on, and a lot of AI techniques are being used in that particular space. So we spoke about lots and lots of innovations and in various space. Fun thing that I really love is the innovation of your AI, specifically in your games. And this industry has really developed. If you have not gone to AI Pictionary, try it out. What it does is, like, it asks you to say create a table, and when you are drawing a table, right, the machine is going to guess, the algorithm is going to guess what exactly you are trying to draw, and on the basis of that, it is going to it is going to do a hit and trial. You get a 30 seconds, and this is the way you can see how machine learning, how that algorithm is learning. So if you draw something and it is not able to identify, it will use it and take it as a feedback, and then it could be used to train the model. So I really like this particular website, and yeah. And again, there's another website where again you start drawing something, and it is going to guess what you are drawing, and it is based on lots and lots of images, lots of data set has been used. These are all your unsupervised learning, because you don't know what the user is going to draw. So that is the way it is learning from that and trying to understand it. And yeah, this is something really I like. And yeah, so I hope this particular session makes you a little aware of what machine learning is doing around you, how exactly it is making a difference in our lives. And next time when you see these particular these algorithms, these systems running around, you can make a guess what is working behind. Is it machine learning? Is it going further? Is it supervised? And really, it will be, I think at your age, it is very good for you to just try to, maybe as an assignment, as your apprentice assessment, whatever, the kind of space you have to do something out of the box, out of your studies. Try it out. You can use Kaggle, GitHub videos, YouTube video, Udemy, lots and lot of stuff everywhere around, because it's the trending thing. And as you can say, like, I really love this particular quote from Bill Gates, which says, a breakthrough in machine learning would be worth 10 Microsofts. Yeah, with this, I end my presentation. Thank you.
Thank you so much, ma'am. It was indeed a brainstorming session that added to our knowledge on machine learning. Thank you so much.
Thanks, Apurva. Thanks for giving the opportunity. If there is any burning question, I'm happy to answer. Not sure what's the time.
Anyone would like to ask any query?
Ruchi, you're on mute.
I guess, ma'am, there are no queries. Thank you so much for your powerful words. Thank you.
Thank you. Thank you so much. Thanks for inviting. Bye.
Thank you so much, ma'am.
Thank you. Bye-bye.
Now let me call upon our third speaker, Dr. M. Tanveer. He is an associate professor and Ramanujan Fellow at Indian Institute of Technology, Indore. He has published over 50 referred journal papers of international repute. Recently, he has been listed in the world's top 2% scientists in the study carried out by Stanford University, USA. He is currently the member of editorial board, guest editor, associate editor in several journals, including ACM, Transactions of Multimedia, Applied Soft Computing, etc. Sir, I request you to start the session.
Yeah, thanks, Apurva, for the nice introduction. Now, I would like to share my screen. Please confirm. Could you please check whether my slides are visible?
Yes, sir.
Okay. Okay, so very good afternoon to everyone. So first of all, I would like to thank organizers, especially who invited me and director of the institute and everyone who is organizing this great event, international seminar on innovative paradigms of machine learning and IoT in human life. It's a great pleasure to deliver my talk here on large scale machine learning algorithms. So essentially, my talk is based on first introductory on SVM, what exactly is support vector machine. So first I'll give just overview geometrically and mathematically, and then some advanced direction.
Sorry to interrupt you, sir. Can you please switch on your camera for a while?
Switch on, right?
Yes, sir. For a while,
Okay.
just for a second.
Yes, please. So if it is okay, I can open my camera, no issue. Okay.
Okay.
So outline of this talk is just to introduce support vector machines for classification problems, and then some advances towards non-parallel variants of support vector machines. First is standard twin SVM, and then it's bounded SVM and its least square version, and some more advanced version recently published. And then we'll come back to the large scale data, how to develop an algorithm for the large scale data, and some algorithm based on pinball laws. So we'll discuss all this, including the ongoing research activities at IIT Indore in my lab. So support vector machine being computationally powerful tool for supervised learning, widely used for classification problem. In the same year, in 1995, it was developed by Vapnik and his team. In the same year, it has been extended for regression problems. So a support vector machine has been applied now almost all the directions. If you look at biological sciences, physics, electrical engineering people, or computer engineering, mathematicians, physicists, so all are using SVM or advanced classification algorithms for their research problem. So the basic idea of support vector machine is to find an optimal hyperplane or a decision hyperplane, so that can separate positive and negative samples. So for example, you can see here we have two kind of samples. So you can see that two kind of dots. So here the basic idea is how to separate this kind of data. So you can see that the data is same. I draw this line. I can also draw another line to separate this data. I can also draw another line. And a lot of lines I can draw to separate this kind of data. There could be some misclassification, means some error, means on one side that another data points may come, but we can somehow classify, and we can find out a lot of number of lines to classify. So the first idea is which line is best. So we'll discuss this one. This is the first idea that we resolve using SVM. So if the data points lie on other side, so we simply called as a misclassified points. So we usually what we do, we penalize and then we just put in the objective function, and then we say we just penalize with some parameter, so to classify it. So what happens if we talk about in a classroom, and in a classroom boys and sitting are sitting one side boys are sitting, another side girls are sitting, and if I want to classify, it's very easy to classify. I just draw a line in the middle and then I can classify. What happens if a girl is sitting inside boys, inside the rows of boys? So then we can penalize that girl, or we can penalize the boy who are sitting in with girls. So, and then we can classify in this way. But what happens if we have a group of students mixed, they are sitting, means boys and girls are sitting, how to classify? It's another challenge, right? So let's discuss one by one. So first is linear case and then non-linear case. So to understand the linear case means if we have data points which can be separated nicely, so by drawing a simple line, so with the concept of maximizing the margin. So what is maximizing the margin? So margin is nothing but the distance between these two classes. So what happens, as I have given one example of a class where girls and boys are sitting, so the best separation will be if we have the distance between boys and girls is maximized, right? So that maximizing the margin, so the first property is coming is maximizing the margin. So if we maximize that distance between one class of samples with other class of samples, so that will be the best classification, right? So this is one way, right? So this is the first property that we just separate with this property, right? So here you can see that here data points which lie on this hyperplane. So middle one is a decision hyperplane, and this two sides, so they usually called supporting hyperplanes. right? And what is hyperplane? Is just a plane in some high dimension. Okay. So here, this data points which appears on the supporting hyperplane are called support vectors. Why we are called support vectors? Because these are the vectors, or these are the points that supports to decide the middle hyperplane, means decision hyperplane, right? So you can see some mathematical way to look at it. So what happens, suppose I have one hyperplane w dot x plus b equal to 1 and w dot x plus b equal to minus 1. So if the data points lie here in the below side, so I simply say w dot x plus b less than or equal to minus 1, and the data points which lie in the class plus 1, I simply say w dot x plus b greater than or equal to 1, right? And the distance between these two supporting hyperplane are called this margin. So we just maximize it. Okay. And what is how to calculate margin? Means distance with a simple distance formula. So it will be 2 upon norm of W. So essentially what happens, so we are maximizing this margin, right? So so to maximize this margin, it means that we have to minimize W. It's a very simple, right? So n equal to 2 upon norm of W. If I want to maximize this capital M, it means I need to minimize W, right? So now if there are some misclassification, so we also add this suppose xi. So xi is some error term, misclassification. So then we penalize, we add in the objective function. So and with the parameter c, here c is to control the overfitting. So it means that the first is this the margin, and the second is the misclassification data points. Okay, so let's just see the overview, whatever so far we did. So we have the standard linear SVM when there is no error. So we simply have W transpose W by 2 subject to the constant that data point should go above class plus 1 and below class minus 1. So and then the new formulation in that case, if for the case of misclassification, so it will be like this, right? So we are just adding this like variables, this xi I, and here xi I is greater than or equal to 0. Okay. So what happens if you look at the overview here? So the classifier is a separating hyperplane, and here most important training points are support vectors because they define the hyperplane. So you can look at it that the data points here appearing in the form of dot product or inner product. Inner product we just usually talk when we are talking about vectors, right? And in general, when we are talking about R, so we usually say dot product. Okay. So now it was a very simple linear case, right? So you can see first example, we just draw a line and there are some data points, blue colors and red colors now, and I want to classify this. So it's quite easy. So one can easily draw a line in the middle and can classify. So it works nicely, right? No problem. But what happens if you look at the second pick? So what happens? We have red data points, blue data points, and red data points. So the question is how to draw a line to classify blue dots with the red dots. Means we have two different class data points. I want to classify it. So you can look at it. So linearly we cannot draw. we cannot draw a line to classify this kind of data. We can do it, but we can classify it some high dimensional data. So you can see here. So what happens, what I did here, you can see I just map from 1D to 2D. So it means that I just take a function fx equal to x square, right? So what in that case, what happens? So the data points will move up, right? When it will move up, so then I can find one line that can classify red data points and blue data points. Okay. So this is just a pictorial representation to classify two different data points. So what happens if we have another complex data? So what will happen? So in that situation, we had to look at it because it was a very simple example, and we see that from 1 dimension to 2 dimension, we are able to classify this kind of data. But if you look at it, it's a highly complex data. So, and we cannot draw a line to classify this kind of data. So then another second property of SVM is coming up here. So it's usually called kernel trick. So what usually what we are doing here, we map this input data in some high dimensional space such that the data point in some dimension is linearly separable. Why I'm saying in some dimension it will be linearly separable? Because I have given one very simple example. So it is linearly separable in 2D. Okay, but it is not possible. This example is not possible to classify in 2D. Right. So it means that what we do, we just transform the given this input data in some high dimensional space such that the data point are separable in some dimension. So how to do that? We just map with the function phi. Okay, so it has some advantage. So I will tell you later. So we transform the given data in some high dimensional data with the map phi such that data is linearly separable. So what is the importance of the phi and what is the nature of phi? We'll discuss later. Okay. So you can see here. So we can simply write if every data point is mapped into high dimensional space via some transformation phi. So we can write phi xi transpose phi xj. So this is a usual way. It's a lot of theory behind it. So you can look at the Mercer theorem that tells us that we are writing this phi x transpose phi x equal to k. So it is coming from the Mercer theorem. Okay, so we usually call it a kernel function. Okay, so you can see that whatever you are considering a function, so we can always write k in the form of phi transpose phi. Okay, and there are several kernel functions available in the literature. So you can see a few are here. So we can use even other kernel functions and even ensemble kernel theory available, multiple kernel theory available, weighted kernel theory available. So these are just an example of kernel functions. Okay, so how to write formulation of SVM for the nonlinear case. This is the dual formulation. So essentially we are doing in the same manner. So the only difference is coming when we compare with the linear with the nonlinear. So in place of xi transpose xj, it is coming k of xi comma xj. It means that this is phi xi transpose phi xj. You see here. This is phi xi transpose phi xj. Okay. So you see also here, I explain. Yeah, this is in place of xi transpose xj. Essentially, we are writing phi xi transpose phi xj in the non-linear case. Okay, so this is the only difference. So what essentially is happening here? It's a very important, and it gives us an impression that we are working on a very difficult problem, but we are solving linearly. How? Because you have seen an example of a complex data, and we are working linearly here. How we are working linearly? Because when we are solving the problem, so we do not need even to know about phi, because we only need to know what is phi xi transpose phi xj, and phi xi transpose phi xj is nothing but it's an inner product, and inner product is nothing but it belongs to R. So it means that we do not need to know the nature of phi. Okay, so it means that the phi is helping us to transform the data from input data into some high dimensional space. So this is one of the nice property to handle the complex data. So now you can look at it, some overview that SVM locates a separating hyperplane in the feature space and classify points in that space. And another, that it doesn't need to represent the space explicitly. So simply by defining a kernel function. As I explained that we are working in the nonlinear case, but we do not need to represent that phi, right? We simply just write phi xi transpose phi xj, and that is nothing but it's a inner product, a dot product. You can say in general inner product, or you can say dot product in feature space. So essentially, kernel function plays a role of the dot product in the feature space. So here you can see some background. So so far I just discussed a brief overview of SVM. Now I would like to just explain some basic mathematics behind it, how it has been developed, and how to write. If we have a formulation, then how to solve it and how to get its dual. So previously, so far I was just showing that this is the formulation, this is the dual, and we are getting this. So it was a quick overview so far. So now I'll try to discuss in more detail. So in case of any doubt, you can ask me any question in the middle, no issue. Okay, I'll be happy to answer your questions. So linearly separable problem. So if we have the training set T, x1, y1, x2, y2, xl, yl, here xi's are input data, and yi class labels corresponding to class 1, class -1, or class 1 or class 2. So, and there exists a vector W, and B belongs to R and positive number epsilon. So we have W transpose xi plus B is greater than or equal to epsilon for yi equal to -1 class, and similarly for class +1, right? So essentially the basic idea of support vector machine is to find a decision hyperplane that is W transpose x plus B equal to 0 between class +1 data point and class -1 data point. You can see that we have the bounding planes corresponding to class 1 and -1. So, and this is the middle one, okay, separating hyperplane or decision hyperplane. And the data point which lie on the planes are called support vectors. Okay. you can see is a more clarity here. So we have the decision hyperplane, and this is supporting hyperplane corresponding to class -1 and class +1, and the distance between these two is called margin, which is nothing but 2 upon norm of W. Okay, and the middle one represents W dot X or W transpose X plus B equal to 0. So this is the basic formulation of support vector machine. We have an objective function half norm of W square plus C summation xi I, subject to the constant of both the classes, class 1 and -1, and xi I is greater than or equal to 0. Xi is a slack variable, means misclassification error. So now, how to solve this problem? This is the first question. So now I will discuss a more general framework first. Suppose I have constraint optimization problem. Okay. Suppose I have the function fx and I have constraint equality constraint gx equal to 0. How to minimize it? And what are the necessary conditions for the function to be minimized with subject to the constraints? So you can see the necessary condition for the x0 to be a solution, that we should have the partial order derivative of that function plus alpha times gx at x equal to x0 is 0 and the gx is also 0. Gx here is the constraint, equality constraint, and alpha is a Lagrangian multiplier. So it's for one constraint, equality constraint. So if we have multiple constraints, then what to do? So we just sum up all the constraints, means alpha 1 g1x plus alpha 2 g2x plus alpha m gmx, right? And here g1x equal to 0, g2x equal to 0, and so on, whatever constraints we have, m numbers, right? So this is the way of solving an optimization problem. So what happens if we have the inequality constraints? If I have gix is less than or equal to 0, so then how to minimize a function? Okay. So in that case, there must exist a Lagrangian multiplier alpha I, which is greater than or equal to 0, such that x0 must satisfy this partial order derivative with respect to x of fx plus summation alpha 1 g1x plus and so on alpha m gmx at x equal to x0 equal to 0 and gix is less than or equal to 0. So essentially the function fx plus summation alpha I gix is known as Lagrangian function. Okay, then we just set its gradient to 0. For example, I have this formulation. So the first is to find out the Lagrangian function. Okay, and then take the partial order derivative with respect to w, b, xi, alpha, beta, then solve it. Right. So and finally we come up with this. We have this objective functions and equality constraints, and alpha is bounded by 0 and c, right? So you can look at the dual formulation here. So the data points here appear in the form of dot product xi transpose xj, or if I have xi transpose xi or xi transpose xj, yes. So what happens here, data points are appearing in the form of inner product. So it means that we do not need to specify the space explicitly. Okay. So, okay, I think those things already done. Now, what to do for the nonlinear case? So you can look here for the nonlinear case. So in place of xi, we are just putting phi of xi. Okay. So, and just take the in the same manner, I just put the Lagrangian function, take the partial order derivative, and then solve it. And what is the difference? So the only difference is coming phi xi transpose phi xi. Okay. So there are some benefits and drawbacks of doing work in SVM, standard SVM, right? So there are a lot of advances. So so far whatever we did, so based on that, I'm just putting some benefits and drawbacks here. So if I look for the benefits, training is relatively easy, no local optimal, unlike in neural network, and it scales relatively well to high dimensional data, and the trade-off between classifier complexity and error can be controlled explicitly. So some drawbacks, the first drawback, I can say more general. So it's an open problem that people are nowadays working on weighted kernel, multiple kernel theory. So it's again a different kind of research field nowadays. And computational complexity is very high. So, but after that, people have developed a lot of different advanced model with less complex algorithm. And the third one, SVM with hinge loss, is sensitive to both label and feature noise. So we'll try to address at least last two issues. So less complex algorithms and how to handle the hinge loss issues. Okay. So this is the first attempt towards a tuned support vector machine. It was published in 2007 in IEEE PAMI by Jayadeva Group of IIT Delhi. So it's a computationally efficient model of support vector machine. It performs classification using two non-parallel hyperplanes instead of a single hyperplane, as in the case of conventional SVM. So let's consider a binary classification problem to classify data point of +1 and -1. So we just represent A is corresponding to class +1 and B corresponding to class -1, and L1, L2 data points belonging to class +1 and -1 respectively in n-dimensional real space, Rn. So the linear tune SVM seeks a pair of non-parallel hyperplane for +1 and minus class. So the idea is that each hyperplane is close to the data points of one class and far from the data points of the other class. Okay, so it's a kind of proximality of the data points. If the data point is very close to this, far from the other data points, we are just considering that class, and we have another data points in this environment. So you can look at the dual formulation. So in the dual formulation, you can see it's quite easy to look at it. So, but the major issue in the 4 and 5 here is that the matrices appear in the dual formulation may not be invertible. Because if it's a very general question, if I have a square matrix, so can I take the matrix invertible? No, in general, no. So H transpose H, G transpose G, they are square matrix, but in general, matrices are not invertible. So how to handle this kind of issue? So we just manually add extra regularization term to make to avoid this issue of conditioning of the matrices. So to avoid this issue in this formulation, so this group in 2011, they proposed another idea. So what essentially they did, they just incorporate extra regularization term in both the objective function. So it's a very small change in the formulation, but it completely changed the nature of the problem. So it's a very nice idea. So what happens after doing this, if you look at the dual formulation 11 and 12 here, so here the matrices appear in the dual formulation is automatically invertible. Okay. Now let's move ahead for another interesting problem. So this is least square version of TwinSPM. So we are aware of that least square formulation are extremely fast because we are simply solving system of linear equations, right? So in the same manner we did here, we just replaced the inequality constraints with the equality constraints, and also another difference, we just take the square of the 2 norm of the slack variables in place of 1 norm. So then this will be our formulation in 18 and 19. So these are just two difference. Just take the equality constant and put the 2 norm of the slack variable. It's a very small difference, but it's completely changed the nature of the problem. It's extremely fast. We are simply solving system of linear equations here. So one can easily solve in 20 and 21. Okay. So it's a general way that when a new data point is coming up and how to classify it. So this is a decision function. So whether the new upcoming this data points, it will belong to class +1 or class -1. Okay. So any questions so far? If no question, then I can proceed.
Yes, sir. Yes.
So it's another interesting problem now. It's a robust energy-based least square TwinSPM. So it published in 2016. So what we did in this formulation, we just introduced an energy parameter to each hyperplane and add extra regularization term to each objective function. So in that case, we can look at the formulation here. So we have E1, E2, capital E1, E2. These are the energy parameters. Okay. And this one C3 by 2 or C4 by 2 and the bracket W1, B1 norm of whole square. Okay. So what happens by giving the flexibility in the hyperplane? So it helps us to improve the performance. So you can look here. So we can get this Z1 and Z2. Means we are simply since it's a least square version. Okay. So when you solve it, so it's we are simply solving system of linear equations. Okay. So what is the advantage actually? So what happens in 2019 recently? What we did by the motivation of one very interesting paper published in Journal of Machine Learning Research in 2014. That the title was something over 100 classifier. Means can we use over 100 classifier? So the idea is that why to use 100 classifier, not one, and which classifier is best. So, and what they did in that paper, so they finally conclude that the random forest is the best algorithm. Right? So then in one of my meeting with one of my collaborator now, PN Sugandhan, so we discussed that can we relook at the TwinSPM kind of formulations and see the comprehensive evaluation and do some statistical analysis to reach at some conclusion whether this twin SVM kind of formulations exist or not. So we got a very interesting results. You can look at it. The rank 1 formulation is RALS-TSVM, which is nothing but we discussed in the last. And fortunately, this work is by my lab. So, and in the literature, means over 100 classifier, over almost all the data sets, UCI benchmark data sets. So RALS-TSVM is a rank 1 classifier if we are talking about binary data sets. Okay. So it's an interesting information here. So what one can do if one is looking for a good classifier, so you can look at those classifier having rank 1, rank 2, and for rank 1, since it is published by our group, so data sets, sorry, all the codes are publicly available in the GitHub repository. I can show it later at the end of my slide. So if any of you are interested, but if you look at my home page, go to the publication page, so you will find out to go to GitHub repository. You'll find out almost all the codes, including this. Okay. So now let's move ahead. Large scale formulation. So far you have seen that we have to calculate the inverse of the matrices. Either you consider TSVM, TBSVM, RELS-TSVM, whatever, LS-TSVM, all formulations needs to calculate the inverse of the matrices. So here the question is coming in our mind, can we ignore this matrix or not? Invertibility issues, can we ignore? Yes. So we developed a model for classification problems which overcome the shortcoming of competing inverse matrices, and essentially we can handle large scale data. So it recently accepted IEEE transactions on internet technology. So what we did here, you can look at equation 1 and 2. It looks like a similar formulation to TBSVM, but the way of solving is completely different. You can look at here Lagrangian functions. So it's a completely different Lagrangian functions. So what is the difference? Essentially, we are considering AW1 plus E2B1 equal to eta 1 as one of the constraints, and putting in the Lagrangian functions. So when we are solving it, taking the partial order derivative and finally getting the KKT conditions. So, and you can look at equation number 9, W1B1, and similarly W2B2. So invertibility issues are not there. So what happens if you have the large scale data and you want to solve it using this formulation? So we can easily do that, right? So okay, these are a few things. I think it may not be necessary. If you are interested, then you can just look at the paper. Okay, all informations are there. So what I can do, I can show some results. Okay, so you can see in the first column, these are benchmark data sets publicly available, but data size is okay, means not big data. So we cannot conclude essentially nothing because our proposed algorithm is for the large scale data and we are comparing with the baseline models. So essentially the comparison is okay. You can look at the accuracy time. So accuracy wise, our formulation is best in almost all the data sets except few. And for nonlinear also, results are better. This is also for non-linear, is better. So what happens when we talk about the large scale data? So you can look at it. If I consider mini boon or connect data 67,000 by 42 or 1,30,000 by 50, it's a large data size comparatively. So you can see the baseline models fail. It will go out of memory, but the proposed model works very well. And another importance, you can look at it, for example, connect. So these TBSVM and TWSVM failed, but RELS TSVM works, but it took time 23,196 seconds. But the proposed idea took just 280 seconds to run this data set. So it means that the proposed algorithm works very well for the large scale data. Similarly here, you can see so we have work for up to 100,000 size data sets. And you can see that the proposed model works fine, but baseline model failed. And these are just some to check the sensitivity of the parameters with accuracy. And finally, we conclude that the proposed model, it doesn't need to compute the inverse of the matrices. Dual formulation is an unconstant optimization problem, which can be efficiently solved using SMO technique. SMO technique is fast and efficient method, which gives better results with less time complexity. So this is another interesting formulation, journal pinball loss twin SVM. So it is also published recently in 2019 and General Tune SVM with pinball loss. It was published in Information Sciences elsewhere. So what essentially we did it here? So we just introduced pinball loss to the original SVM. Okay. So rather than having hinge loss or other loss function, we introduced pinball loss. And we got a very interesting results. So, and you can see equation 4 and 5. If you just put tau 2 and tau 1 goes towards 0, so essentially the second constant of both the problem, it moves towards xi1 greater than or equal to 0, xi2 greater than or equal to 0. It is essentially twin SVM formulation. These are some results. You can look at the average rank, some statistical analysis, and you can find that the proposed model is better. Okay, so now I would now start discussing some information in another 5 minutes. And after 5 minutes, I'll take a few questions for another 10 minutes. Okay, so these are a few research projects ongoing in my research lab, which is based on classification and prediction of Alzheimer's disease using multimodal imaging data. It's funded by DST SCRB under Ramanujan scheme. And the second is under Early Career Research Award scheme. It's based on optimizational models and algorithm for non-parallel SVM. And the third is funded by CSIR under EMR scheme on detection of human brain disorders using novel machine learning approaches. And a few more based on EEG signals to develop a new machine learning algorithm. And the fifth one is digital forensic knowledge integration and intelligence. If any of you are interested, you are welcome to contact me directly so we can have do some kind of collaboration if you are interested and have some experience in this area. So I would like to acknowledge my funding agencies, my institute for the support. Okay. Here, I would like to invite you to submit your high quality work in these high quality journals. So the first one is IEEE Transactions on Emerging Topics in Computational Intelligence. Last date is 31st March 2021. So we have just 1 month more. So you are welcome. Please check the title and the other details. Title is here, Emerging Computational Intelligence Techniques to Address Challenges in Biomedical Data and Imaging. And second, in another top journal called Annals of OR, of a Springer journal, Robust Data Analysis and its Applications. So data are somehow similar in both the special section of the journals. And now I would like to invite you to submit your high quality work in MISP 2021. So it will be organized in NIT Arunachal Pradesh during September 23 to 25. So last date of paper submission 1st April, and all paper will be accepted, published in Springer proceeding. Okay, Scopus Scopus indexed. So, and some more selected papers will be published in some journals. Okay. So for more information, please just visit the website MISP 2021 NIT Arunachal Pradesh. You will get it. Okay. So here, I would also like to invite you as a publicity chair of 28th International Conference on Neural Information Processing. This is ICONIP 2021. It's a core rank A conference. So it will be at the end of this year, 2021, in Bali. Bali is one of the most beautiful place. So if any of you are interested, yeah, please submit your paper and visit the good place. And I'll be happy to help you in case of any. And this is a kind of announcement at the moment. It's a 29th International Conference on Neural Information Processing, same. This is 2022 actually. Yeah, sorry, I missed here. So it will be 2022. It will be tentatively in December 2022. So this is first time, I think, to my knowledge, in India to have a core rank A conference in the area of machine learning and artificial intelligence. So I'm journal chair of this conference. So you are welcome to submit papers next year in this conference, and you are welcome to be a part of this conference in general and several other committees. Okay, and these are some references I used in my slides, and thank you so much. And now I would like to take a few lectures, a few questions from the audience. I'll be happy either some advanced level questions or basic, whatever in your mind, please ask. Okay, and if you want to discuss with me, you can just drop an email to mtanveer@iiti.ac.in. Okay, I'm available here. Yes, Apurva, madam.
Yes, sir.
So in case of any question from the audience, please take a few questions.
So currently in the chat box, I don't find any questions.
I don't know if people are following my lectures or not.
No, so they are following it, but there are no questions, there are no queries.
So
Thank you so much, sir, for informing us about the various research projects and the various conferences at various places. It was indeed a very valuable knowledge on machine learning you shared with us. Thank you so much.
okay, thank you so much, everyone. Dr. Apurva, Dr. Ruchi, Dr. Vikas, and everyone and the organizing team. Thank you, everyone. Thank you.
Thank you so much.
Thank you.
Now I would like to call upon HOD CSE, Dr. Vikas Chaudhary, sir, for a vote of thanks.
Thank you, Tanvi sir, for the nice session. Really, it's a very wonderful session given by you.
Okay, thank you. Thank you.
Good evening, one and all. At the end of this international seminar, I, Dr. Vikas Chaudhary, head CSE department, privileged to have the opportunity to thank all the stakeholders of this wonderful event. I give my sincere thanks to all the eminent speakers, Dr. Mohammad Ayub Khan, Dr. Shruti Kohli, and Dr. Amit Tanveer of international repute on sharing their incredible knowledge. I am sure that our students and faculty members will take advantage of this seminar. I am sure that I would like also to thank our audience and organizing team members, Dr. Ruchi Agarwal, Ms. Namita Singh, and Ms. Kalpana Jha and Ms. Apurva Jain in the planning and conduction of this seminar. At last but not the least, I am very thankful to our Honorable Chairman Dr. Amit Gupta sir and Director Dr. Ajay Raghuvanshi sir for giving us this opportunity. Thank you.
Thank you so much, sir. I once again thank all the speakers. We are now closing the session. Thanks everyone for joining the session and making it a success. Thank you so much. Have a good day ahead.